In this lesson, we're going to solve quadratic equations by factoring. So a quadratic equation is in the form of y equals ax squared plus bx plus c. This is the general form of quadratic. Here are some examples of quadratics. So 2x squared plus 3 is because our highest power is x squared here. Again, our highest power is x squared. Highest power is x squared. One way to solve for a quadratic is solve by factoring. So this strategy depends on the zero product property. That is, if a, b is 0, then a is 0 or b is 0, or a and b are both 0. So let's try to solve for this first example here. We're going to do it by factoring. So we're going to factor this. First, that's your first step. And we're going to factor this as normal. There is no number in front of the x squared. So I'm going to look at factors of 9 then, which is 3 and 3 are 9 and 1. And I'm trying to recreate that middle term of 6. So if I have positive 3 and positive 3, that will give me a 6 if I add them together. And if I multiply plus 3 and plus 3 together, I get a positive 9. So remember that this was equal to 0, so don't forget to write that back in. Our second step is to solve for each set of brackets. In this case, we only have one set of bracket because they are the same. They're both x plus 3. So we're going to see when x plus 3 is equal to 0. Now, if I move this 3 to the other side, or in other words, subtract 3 on both sides, we're going to get x equals negative 3, and that is your final answer. So why don't you try the next one on your own? You're going to factor it, and then you're going to solve for each set of brackets, and you're going to set them each to 0, and then solve for x. So go ahead and do that, and then when you're ready, you can press play again. Okay, so here's the solution to b. When you factor, you should get x plus 7 in one set of brackets and x minus 3, because 7 times minus 3 is negative 21, and if you add 7 and negative 3 together, you will get 4. So then afterwards, you want to solve for each set of brackets and set it equal to 0. You're going to move this 7 to the other side, which is negative 7, and move this 3 to the other side, which is 3, so your answer is negative 7 and 3. For C, we're going to have to factor a little bit differently using the box method. So I'm going to look at factors of 2, which is only one set, it's 2 and 1. And factors of 5 is also just one set, which is 1 and 5. I'm going to place that down there. Then we're going to multiply them across. 2 times 5 is 10. 1 times 1 is 1. And I'm trying to recreate this negative 9 with these two numbers, and I can if I had a negative 10 and a positive 1. So this negative is just going to go back up here, and that's what's going to go inside my set of brackets. Remember, the top numbers do have an x with it. So this is 2x plus 1. The other one's x minus 5. Okay, so the next thing we're going to do is set each of these brackets to 0. And then we're going to solve for x for each. So if I rearrange this, this is 2x minus 1, divide both sides by 2. One answer is negative a half, and this other one is going to be 5. So therefore, final answer is x is negative a half and 5. Once you get to this stage, this is all I really need to see, because you can jump from here to your final answer. So if you don't want to include all this work, because you can do it in your head, that is completely fine. But I'm just writing that in so you understand the process. So what we need to do actually first is expand this and then move this 3 with everything else when we collect like terms, and then reset it equal to 0 and then factor again. So I'm going to multiply this 2x with the x and the 2x and the 1, the negative 3 with the x and the negative 3 with the 1. So we're going to expand on the left-hand side. That's 2x squared. 2x times 1 is 2x. Negative 3 times x is negative 3x, and then negative 3 times 1 is negative 3. This is still equal to 3 right now. We're going to collect our like terms. I'm going to move this 3 to our left side by subtracting 3 on both sides. I'm going to rearrange here. And then I'm going to combine this 2x and minus 3x, which is just negative x. Negative 3 plus negative 3 is negative 6. And now this is equal to 0 because I subtracted 3 on this side. Now I can factor. And we're going to use the box method because we have a coefficient in front of our x squared. So our factors for 2 is 2 and 1. And our bottom one is 3 and 2, or 6 and 1. But this 3 and 2 is going to work. So 2 times 2 across is 4. 1 times 3 across is 3. And if I had a negative 4 and a positive 3, I can recreate that negative 1. Those are what's going to go in my brackets. So we have 2x plus 3 and x minus 2 is equal to 0. And then now we just solve. So we can solve exactly like what we've done before. So x is negative 3 over 2, and then the other x is 2. And then we're done. And this next one, I'm going to move everything to one side so we can have our polynomials equal to 0. So I'll subtract both sides by 4x. So we have 2x squared minus 4x is equal to 0. Now I can factor, and these two terms have 2 in common as well as x. I'm going to factor to 2x. Then I'll be left with x minus 2. Okay, so I'm going to solve for each. So that's 2x is equal to 0, and x minus 2 is equal to 0. So that means if I divide both sides by 2 here, I'm still going to get a 0. If I move the 2 to the other side, I'm going to get 2. So your final answer is 0 and 2. Another topic we're going to cover is the remainder theorem. So the remainder theorem states that if a polynomial is divided by x minus a, some sort of binomial, and a remainder r is obtained, then we have p of a is equal to r. So that means I'm going to plug in this number, whatever it is, into our polynomial to figure out what the remainder is. I think this will make more sense with an actual example. So I'm going to plug negative 3 into this polynomial. So how you think about this is we're not going to plug in 3, but negative 3 because this says x minus a and we have an x plus 3. So really a is negative 3. We're going to plug this into our polynomial. I'm going to call this p of x for the name of a polynomial. I'm going to put this x equals negative 3 into each term of x. That's 4 times minus 3 squared plus 12 times negative 3 plus 9. Just get rid of this 15. I don't know where that came from. And then we're going to evaluate this and see what our remainder is. So that's 4 times 9 minus 36 plus 9, which is 36 minus 36 plus 9. So we're left with 9. This is not 0. So that means if I divide x plus 3 from 4x squared plus 12x plus 9, our remainder is going to be 9. In order for a binomial to be a factor of a polynomial, the remainder has to be 0 because you want to divide evenly so you don't get a remainder. In this case, we have a remainder of 9. So that means x plus 3 is not a factor of p of x. Because you have a remainder of 9 and not 0. Okay, for this next one, this is where the 15 was supposed to go, so probably want to put that in there. We want to see if x plus 3 is a factor of our polynomial now. I'll still call this p of x. This is your polynomial for the side. So again, we're going to plug in x equals not 3, but -3, because this theorem works for x minus a. So then, because we have a 3, positive 3, that means we had a negative. So I'm going to plug this into this polynomial here. So we have p of -3 is 2 times -3 squared plus -3 minus 15. So again, I'm just plugging this x value into every x that I see of p of x. And now I'm going to simplify. So -3 squared is 9. 2 times 9 is 18. So 18 minus 3 minus 15 is 0. So that means x plus 3 is a factor because we have a remainder of 0 when we plug it into our p of x. Now we have one more set of examples here, and it has to do with word questions. So now that we know how to solve for quadratics by factoring, we can apply this to a word problem now. So we are given the function already for the quadratic, but we also need to understand the context. So we have a dog event where dogs complete the longest jumping distance from a dock into a body of water. The path of a Jack Russell Terrier on a particular jump can be approximated by the quadratic function given to us, where h of d is your height and d is the distance the dog travels. And we want to find the horizontal distance for the jump. So we're trying to solve for d. We're going to assume that we don't have a height. That's because if you think about this path, it's a parabola. Okay, so we do need to take on this shape. Your height's going to be 0. This is what we're looking for, and the height is 0 here. On ground level. Okay. So if h of d is 0, that means I'm going to replace that with 0. And I know this is equal to -3 over 10 d squared plus 11 over 10 d plus 2. So if we want to solve for d, we're going to have to factor here. This is kind of a review of how we would do this before a factoring. So I'm going to take 1 over 10 out, and if I do that, that means I'm going to multiply each term in here by 10. So then I'm left with -3 d squared plus 11 d plus 20. So this was from our first lesson in quadratics. The next thing I'm going to do is also take out the negative, because we don't really want to have a negative in front of our d squared when we're factoring. And that's going to change the signs of everything inside the bracket. Okay, so now I am going to go ahead and factor this using the box method. So 3 and 1 is our factors for 3, and then for 20, it's going to be 4 and 5. And we're going to cross multiply them, so 3 times 5 is 15, 4 times 1 is 4 to find that middle term. And we can get that middle term with a -15 and a positive 4. So this negative goes up here. And this is what we have in the bracket. 3d plus 4 and d minus 5. And now we can solve for this because each of these, 3d plus 4 is 0 and d minus 5 has to be 0. And then if that's the case, we're going to get negative 4 over 3 once we solve for 3d plus 4 equals 0. And then d minus 5 equals 0. If we solve for that, that means d is 5. Now to think about what we're actually solving for. This is a distance. So a negative distance doesn't really make much sense with our context. So we're only going to take d equals 5, which is a positive distance. And this was in feet according to our original question. Right there, in feet. And then part B, we want to determine the dimensions of an outdoor lacrosse field. We know that this field is 10 meters less than twice the width, and we know the area is 6,600 meters squared. So we're just going to represent our dimensions in terms of W. I'll explain why in a moment. So we know the area of any rectangular shape is length times width. You know what the area is. It's 6,600. And we're given a piece of information here. The length, so this L, is 10 meters less than twice the width. So 10 meters less than 2 times the width. So that is your length. I can leave width alone as just width. So this is your length and this is your width. So once you represent this in terms of W, we are done. Your length is 2W minus 10 and your W is just your width. If we actually want to solve for this, you could try, but the problem is you're going to have a hard time factoring it because it's not factorable in terms of what we've learned so far, but later on you're going to learn about the quadratic formula and then you can solve for something like this. But for now, just leave your answer as so. Okay, so that's it for this lesson. You're going to have to do the rest of page 11, which is the next page, for your practice.